Welcome to HB Tuner's GM Gen 5 Training Part 17. In this training module, we're going to be exploring the basics of spark timing within the Otto cycle. We're going to have a lot to cover. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our spark timing within our internal combustion engines for this tutorial. This is going to be more of a broad, general approach to looking at spark timing. We're not going to talk about the Gen 5 specific spark timing tables, how they all fit together, the knock control. We're going to be doing that in future training modules coming up here very shortly. This tutorial is just focused on the basics. What is spark timing? How does it work? What do the values in the table mean? Just understanding what is going on here. It's very, very important. So the first thing we're going to do is open up a calibration file so we can find where the spark timing tables can be sourced at, and then we'll open up a base timing table and talk about why the table has the values shaped in the table. It'll make a lot more sense if you've opened up the spark timing tables and looked through the calibration file and things are confusing. This will be very clear as to what we're trying to accomplish here after you've watched this tutorial. So the first thing I'm going to be doing here is taking a look at a 2018 Yukon Denali file. Any Gen 5 file will work, so you can follow along. Don't have to be a 2018 Yukon Denali file. We're going to go up here into the Engine tab and then go from General here over into our Spark tab. And here we find 4 separate sub-tabs. We have an Advanced tab, we have a Retard tab, we have a Dwell tab, and then a Knock Sensor tab. We're focusing just on the Advanced tab right now, and we're specifically focusing over here on our base values. Now in our base values, we have 5 base timing tables. We have a low and a high octane. This is a function of the knock control system, and we'll be talking about the knock control heavily in another training module. We have a dual pulse, double spark type of mode that's only used, and we typically don't use this table, that's only used if our multi-pulse spark here option is on, so this table is not used at all. And then we have our low and our high octane tables with displacement on demand. So if you have the variable displacement option on your engine, I have that on my Yukon Denali, it can source the spark timing from those specific tables when we're in that displacement on demand type of situation. For right now, all we're going to do, we're not going to worry about why there's 5 tables and how they all fit together. We're just going to be focusing on opening up our high octane table and talking about just the fundamentals of spark timing. What do the values in this table represent? Why do we have an axis based on something called spark air mass? What does that even mean? Let's dig in here and let's understand what is going on. So let me move my table over here to the upper portion of the screen. Okay, let's talk about the values in the table. That's probably the most confusing part of spark timing. These values are going to be commanded in degrees before top dead center. So we're going to find here, if we're looking at the map, we're going to find here's a value of 54 degrees. This would mean that we want to fire off the spark plug 54 degrees before top dead center on the compression stroke. If we look at a value going further down towards the base or the bottom row here, this is going to be 2 degrees before top dead center. A pretty large spread of the values that we're programming in here. So what does that actually mean? Why are we doing that? Let's first discuss what the value here actually represents. Let's take a look here at our Excel spreadsheet. Jumping into the spreadsheet, specifically on our start of injection page, we're going to find this nice graphical plot that we've talked about when we were referencing our start of injection, when we were looking at our direct injection operation. So we know when we're referencing the unit scale in crank degrees, when we're referencing our start of injection, we're referencing everything as we have a top dead center point where 0 degrees is referenced as that point between our compression and combustion stroke. So when we're looking here at the way this is going to work, if we're going backwards in our Otto cycle, so going from that TDC mark to BDC, bottom dead center, moving through the compression stroke, this is going to be 180. Going backwards yet again, this is going to be counted as 360. This is TDC between the intake and exhaust stroke. And when we're typically referencing our Otto cycle, 0 degrees is normally referenced as this TDC point between the intake and exhaust stroke. And then as we move forward here, this would be 180, this would be 360, this would be 540, and then coming back around again, this would be 720 or 0 degrees and starting off the Otto cycle again. Now in this situation here, what we're going to be finding is that the values are referencing the same type of operation as our start of injection. So meaning start of injection references points at 0 degrees, this is at 360, and we know we command that start of injection point somewhere in the range right here, ideally, and it's going to usually be after exhaust valves closing, so we keep the fuel.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.